Good afternoon, guys. Hey, as we were so greatly introduced, we're here to talk about automating our way out of federal data centers using automated image pipelines. So my name is brought up Nicholas Mellon. As an associate manager at Accenture, I am currently supporting a variety of civilian, defense, and intelligence clients in their cloud operations or shifting their workloads to the cloud, as well as containerization. Marcelo?
Hello, everyone. My name is Marcelo Zambrana. I'm a cloud solution architect at Microsoft. I specialize in application development, infrastructure, automation, and anything DevOps, basically.
So why do we really need image pipelines? And sort of what do they serve? So across a lot of our experience, which is both development and infrastructure, in commercial or federal, and with all of the major cloud vendors, we've seen some really terrible image practices going around, some really tough stuff. We've seen, in particular, I've run into secrets management in images, which is just an atrocious image practice. Outdated dependencies or even kernel exploits that live on inside of images for years inside of an organization unpatched. Image sprawl and maintenance issues, just general management concerns with how many images and what types of images are floating around. And in the federal space in particular, you run into source verification, where you've got things like zero trust networking and zero party trust, where you can't really trust the source of your image that just was given to you by the cloud provider. So how really then do image pipelines help solve those problems? Well, we think that an image pipeline fundamentally treats images as an artifact, just a simple output of a pipeline or as part of the process. In that, we have a process architecture where you've got clearly defined and repeatable flow of images moving through this pipeline. You can clearly add and change capabilities, alter your pipeline to add different security or application parts into it. We also think that image parity is a real benefit of the pipeline approach. If you've done work with banks, you've done work with healthcare, you've done work with government, you are trying to solve the parity problem. And I think that the pipeline approach helps you quickly put the same thing in different clouds with one repeatable code-based process, which then gets into image segmentation. A lot of organizations out there are using images as a part of the base for each type of application. Each Rails app, each Python app, each Spring app, they've got that type base image. So what if we were deploying out new ones and supporting them through pull requests? What if we were managing them completely as code and bringing in new images and testing them with clearly repeatable processes? And finally, probably the biggest benefit, and what we like to demo to people, is continuous environment delivery. This ability to ship an image, and maybe let's say a version of CentOS or a new RHEL image that you received, a minor patch, let's say to RHEL 7, you can send that out to all of your cloud and on-prem environments with a single push and pull request. So you can do these things on your timeline, not necessarily when you have time and you can get a story open for it and an infrastructure engineer to support it. So what about the leaving data centers part of it? I put that in. I think we both think that it's kind of flashy, but this actually helps. This really comes into play here. A large amount of what we do with the federal government involves using cloud better, not just moving to it. And we think that using automation here is a key part in the pipeline approach. So in our personal experience, we've even done things like application rationalization, where we built custom tools for scanning through a data center and trying to figure out what images that we need to use. But we've also used COTS products. There's a lot out there. Even ServiceNow is trying to get into that game, right, of like scanning through your environment, telling you what you have, giving you visibility. Scope management. Every time we are asked to do new features for the federal government, oftentimes they wanted us to do it with the same number of dollars. So we say, okay, great. Can I automate this change in scope? Can I automate my approach to those new parts so I can try and squash technical debt before it even comes into play? We want platform to platform. We work with all of the cloud vendors all of the time across a multitude of clients. So we need the ability to, inside that particular space, shift images around and to clearly repeat our processes for moving into them. And of course, testing. I think there's very little out there on the process of validation, independent validation and verification testing on images. And now we have a repeatable process for applying that in your organization. So that's sort of how that fits in. What actually is an image pipeline? We're getting more into the nitty-gritty a bit. As I mentioned, everything is managed as code. So in our approach, you're using your source code management solution to have a Git ops usually, or some kind of Git flow workflow for your code, and mirroring that up with some CI/CD orchestrator to run a process whenever you've put together and signed something that you actually want to go out to production inside of your cloud environments. With that in place, your pipeline can actually trigger, where you're going to dynamically create a builder using an infrastructure as code solution, apply configuration management changes to the actual image itself that harden your image, maybe using federal standards, or possibly add your organization's specific implementation strategies to that image. Testing that image using a variety of different testing suites or configuration management suites. And then finally, the continuous deployment to the actual cloud environments and the on-premise environments if you still have them or working with them. So let's turn it over to Marcelo to talk a little bit about our actual image pipeline approach that we've rolled out with certain clients.
OK, thanks, Nick. So let's try to digest this diagram. So our goal was to, when we started this, we tried to design, build this architecture. We had one idea in mind, to be cloud agnostic, right? And we also had the idea to support not just one cloud, but multiple clouds, and on-prem, of course. Because realistically, in most of our experience, we always need to support at least one more cloud, right? It is a fact. You need to be able to support a hybrid environment. So if you see there, we start with all the source code that we need. That implies Packer scripts, Terraform scripts, chef recipes for the hardening. It could be Ansible there too. Kickstart configuration files to automate the initial setup and configuration of the initial baseline. And we store everything in GitHub, right? GitHub allows us to trigger these Jenkins jobs, right? And if you see there, we have our Hyper-V environment, which is basically a Jenkins slave, right? So it assigns that task to that slave and starts getting all the source code from GitHub, all the Packer scripts, all that stuff. Depending on which cloud we're going to build, we have a different set of scripts for each one of them. And this is because, sadly, each cloud environment has its own requirements, initial base configurations that need to be there before you can import an image, right? That's a fact, sadly. I tried to make it work with just one generic thing that might work. It was a mess. It was really sad. It didn't work. So I said, let's divide and conquer. So now we have a set of scripts for each cloud environment we want to support, right? So one thing to notice there, you see that we have a CentOS logo. We are grabbing the initial CentOS baseline from the official repo. But that could be a local path in your internal network, right? It doesn't have to be, but it could be. In our experiences, sometimes it's really hard to get those base images from outside. That's why it could be there, but it could also be internally. We support that too. So once Packer does all its magic, runs everything, we harden that using chef recipes, and we have the VM ready, we export it as BHD file. And then we start the process to import those BHD files into each cloud environment and on-prem, right? So again, there's a lot of configuration in place there, mostly because along with the import process, there is initial configuration that needs to be there, right? In Amazon, you need to have an S3 bucket. You want to make sure it's secure so you don't leak images outside, right? We don't have open S3 buckets there. Storage accounts. In GCP, we need buckets, things like that. And not that, we also need permissions to access those resources. So there is some initial configuration that need to be there, but we use Terraform to automate all that stuff. It doesn't matter if it's on cloud or on-prem. We automate all that base configuration and the import process, so we have everything ready once Packer is ready to import the image. So yeah, Nick is going to show us a demo of all this process. But yeah, that's our architecture. And again, we try to do something cloud agnostic that will allow us to extend it and support multiple clouds at the same time. So all these, as you can see, we have a lot of tooling there. And let's start with Jenkins. So Jenkins, Nick is going to talk about why we're using Jenkins to orchestrate all these things.
So yeah, let's talk about Jenkins because we know, we've seen it, we've seen the posts, we've seen a lot of blog posting on this. Like, people are using Jenkins for probably far more than they should. I think we could all agree that there's a lot of people that do this. But this particular solution, Jenkins was actually quite appropriate.
Yeah, especially for our customers,
right.
Government agencies, Jenkins is pretty much always there.
Jenkins is already there in with most of our clients. On the rare occasion that they're not already using Jenkins, they're a complete .NET shop, and they're looking at Team Foundation, if you want to go way back, or
Azure DevOps.
He works for Microsoft. Did you know that? Now, some of the other reasons why Jenkins came into play here, we can have a stateful process in our pipeline. So inside each stage and inside each shell declaration inside that stage, we have state. So we can easily work with tools like Terraform or Packer. It's a lot easier to work with at Chef. We can support parallelization very quickly. I mean, it's an additional 3 lines of Groovy to support parallel build stages. And when we're parallelizing certain jobs like image management, uploading, things like that to the multiple clouds, it's a big time saver. I would argue that there really weren't any other options that can address some of these needs, but feel free to duke it out with me later. And of course, we can use Jenkins to offload the actual work of deploying images and configuring things inside of them, exporting them into other formats, and sending it to the cloud on other machines that can be remotely controlled from Jenkins. So I think that's a major way Jenkins plays into this. Marcelo, do you want to talk a little bit about Terraform?
Yes, so as I was saying before, we did use Terraform a lot, right? We tried to automate as much as we could, right? And in order to support multiple clouds and on-prem, so Terraform was basically the best choice, right? Let's be honest, who here likes writing and managing CloudFormation scripts or ARM templates? Anyone? Don't be shy. Nobody? Yeah, that's what I thought. So again, we could use those cloud-native tools, but again, it wasn't something we wanted to do because the learning curve of learning those things, maintaining those things, it was just not nice. So we went with Terraform, and we also used Terraform Cloud, right? It was released already for everyone. I highly encourage you to use it. It's really easy to start, and it allows us to manage the remote state, right? So that's what we want. We want to group all developers to use the same remote state. So it was great. It was fast, it was nice, and everything was supported by Terraform, right? Especially for us, it was really easy to start with that. So kudos to Terraform. And of course, Packer. You can say, yeah, it is a real worker here. At the end of the day, it's an image pipeline, right? And that's what Packer does. So the ability to support multiple provisioners, providers, post-provisioners, again, it was a nice choice for us. It was really nice. Even if you don't have something, you can extend it. I think there was a nice session yesterday on how to extend Packer. So it was really easy for us to choose Packer. And to generate all these builders, it was really nice, easy, and straightforward. But all this tooling, all this scripting, it had a goal, right? We had to meet compliance requests from security. And Nick is going to talk about compliance now, the fun stuff.
The fun stuff. So we were really trying to seek, in particular, disk-to-STIG automation to start, but this really branched out in the ways that we could meet compliance objectives inside federal agencies. The first concept, which you might have already heard of before and is used without automated pipelines, are gold images. These are central images that are trusted by agencies to operate their applications on top of. So we sought out to build those gold images from the pipeline. That is the genesis of this talk and all of the other work that we've done here. But there were other things that we could benefit, right? We were able to really reduce deployment overhead. So we were able to take that infrastructure engineer that spent way too much time navigating through individual clouds and on-premises solutions for importing an image and then working on them manually, making STIG hardening or other compliance changes to those images. And they can focus now on making those changes as code and being faster and more responsive to changes inside those formats. Of course, you can stig many images with this approach. You can stig all of your base images and start having new application types quickly rolled out on top of your gold image. System parity, I hit on parity earlier. And I just want to really drive that home that we are achieving parity much faster than other people working in the space because we have a pipeline constantly delivering the same image that can be independently verified inside each cloud or on-prem operating space. Everything's automated and deployed as code. So we can test that code and we can validate that code and provide that as a metric to the government when we're describing what we're doing, what we're up to, and how we're supporting them. And of course, there's way more room to extend this solution. You could do additional security checks, for example, like what you see in container security space with CIS guidelines, checking for like private keys inside images. You can really go really deep on this approach. But of course, the main thing that we were seeking to address were DATACENTERs. So let me do my absolute best to show you a demo of what this type of pipeline looks like. So I'm just going to go ahead and dig that up right now. So pop that for a sec. And let me shift this over.
Are you building one right now?
I'm building it right now. It's great.
So one thing about image pipeline takes time. We're going to talk about that in a minute, but it does take some time to build all these images, harden them, and then import them. But yeah, you started one.
Yeah. So this is me starting it. We froze this demo. These pipelines take a while to run, of course, because we're doing quite a bit of work on the backbone. So let's just walk through that a bit. So in a typical scenario that we are running with the government, we actually dynamically build the so-called builder VM, which is a Win10 or Win2016 VM.
2016.
Yeah, using Hyper-V as the base for Packer, if you guys are wondering from a technical implementation standpoint. With that now built, it already comes pre-configured with the Jenkins JNLP agent, and then we reach out and it starts checking out the actual repo of our images. We usually define the images. For our little toy demo that we wanted to show you guys, we just wanted to show moving an image to each cloud. But you can take this way further and have folder level organization of the types of images you want, and your pipeline automatically sends it to all three clouds, or wherever else you're going. Moving a little bit forward there, we have local build directories that have those VHDs, wipe them all out. And then we move into running Packer build operations. And those of you that are familiar with Packer, in particular maybe using Packer with Hyper-V, know that this is very resource intensive, and also it's, I don't want to say like a black box, but it's a little bit harder to really understand where those resources are being allocated at any point in time unless you have a really good view on the metrics of the server. So we actually did a little bit of testing on this and found out that the Packer builds were faster if we ran them in series, not in parallel. So that was an aspect of parallelization that wasn't necessarily helpful. So we started off here with Azure. And if I can just zoom it a little bit forward, we go through each cloud process here. So there's an Azure build, AWS build, and then a GCP build. And in each one of these, if I can get it to the
Who's using other clouds besides Amazon, Microsoft, and Google?
That would be cool.
Oracle? Okay.
Yeah.
Anyone else? Yep.
So what I'm trying to zoom in on here. There it is. So for the provisioner, so if you guys are kind of going through the Packer build process, you've got the actual input where we're taking, in this case, an ISO and a Hyper-V. And then you actually need to apply that hardening profile, all of those different security checks that you want to do to the image. So we use Chef for that. And in particular, we usually did a stig. We would do like the rel stig or the CentOS stig. CentOS. And we, of course, would run through all of that process. We'd also apply like agency-specific things. So if you've ever worked with like DHS, they have a different handbook. It's DHS 4300A. And that governs how to configure those systems for sensitive workloads. And we configured all of that with Chef. We manage those recipes internally. And that is typically how that workflow works. If I move a little bit forward, after those Packer builds, we take the output of those are all VHDs, right? We ended up consolidating it all to VHD, which is great because one format kind of rules them all. It really helped us out. Send all of these to the right cloud storage solution. So if you're using AWS, their process is you bring it into a bucket first. For Azure, it's a storage account. And for GCP, it's also a bucket. So sending it first to these buckets, and then the next hop is actually ingesting it. Now, one little plug I'd like to point out here for any Google fans in the audience, they have actually united these into one single step in their approach. So a little plug for them. It's a beta feature at the moment. It's beta, but you can now go directly from VHD to final running image inside their cloud. Everybody else, it's a minimum of 2 steps. Now, after we finish up the upload, which takes a little bit of time, we will then finish it up with, that's Google telling you that it's done. Great. There's a lot happened here at the end. Let's break that in a little bit. So importing that image then typically is a process of taking your VHD that you created that's in the bucket and making some kind of managed volume or managed disk off of it, depending on the cloud provider, and then creating a test bench of it and snapshotting that. So there's your image. So that is that second step, or that step after cloud storage offerings. And then the test rig. So we kind of zoomed out from Terraform earlier, but I want to go back into it because this is another important approach here. Our process for actually testing and validating these images isn't some sort of checksum or something on the image. We're actually running this image in the target cloud or on-prem environment. We're building a test rig up with Terraform, and then running a test suite against it. So we would write, let's say, a STIG profile in Chef, and then we would write a STIG testing profile in Ansible. This allows us to have a tool-agnostic approach, really, towards the process of applying STIGs and analyzing them in our target environments through our pipeline. So we would test using things like Ansible, or possibly test with even just regular Python if we're looking for different things on the OS. But yeah, that would actually be sort of the final endpoint of our cloud pipeline. This would result in your images now from that single physical medium, an ISO, that you could grab from a secure disk, a disk that you don't really have to worry about where it came from. It can just go into the pipeline now, all the way into cloud images.
But if you notice here, it took 1 hour 42 minutes to finish this thing. So it does take some time. So we wanted to demo it, to be honest, but the session is not that long, so
didn't want to make you guys.
We will have a lot of time for questions, but yeah, it's a lengthy process, especially if we are supporting multiple clouds and the way we're doing it with testing, it does take some time.
Yeah, absolutely. Cool. So Marcelo, do you want to talk about? So that's just an example of what we did. Do you want to talk about our general lessons learned?
Yeah.
Actually, about what we really did.
Let's talk about it. So lessons learned. But it's not as easy as it looks. Actually, it is, well, it's not easy. For sure, image pipeline requires patience, a lot of patience, right? Each time we are testing each environment, it takes time. Remember, each time we are creating a VM, right? So from a baseline official image. So it depends on how big is going to be the disk, the VM that hosting, the Hyper-V environment, things like that. I think we started with a disk, 30 gig disk. It was a pain. It was just to test simple things. We had to wait like half an hour or sometimes more. Yeah. Now I think we are down to 10 gigabits disk, and it still takes some time. And we play with some metrics like increasing to more CPU-focused VM, I/O, things like that. Probably we can tune a bit more. But again, you need patience to do this stuff. So it requires a lot of time, patience, and it's time-consuming, sadly. But once you have it running, it is easy to make changes and move forward. But the initial environment, yeah, it takes some time. And going back to environment, each cloud, sadly, has its own requirements. So that's something also you need to take in mind. You need to do some initial configuration, VNet, subscriptions, storage accounts, subnet, NATing, IAM policies, things like that to grant access to the pipeline to all these resources. As I was saying, more clouds, more complication, right? So it takes time. To make it work properly, especially when you distribute that work to multiple clouds and environments, it's a lot of complexity to handle. And well, I don't know if you guys are familiar with Kickstart configuration files. How many are familiar with those for CentOS?
That's a little Kickstart, yeah.
Yeah, so I'm just going to say testing those files is hard. That's the nice way to put it, those, because they change based on the version you're using. It is complicated, especially because when something is run, the way to debug those is complicated, especially in a cloud environment. But let's put it that way. It's hard to test those.
A lot of back and forth.
Yes, it is painful. And the import process, again, there comes again that each cloud has different process to do this. For some reason, Amazon requires a JSON file. I don't know why, but anyways. Then you cannot even name the final image. So, but you need to learn all those, have everything in place. And it takes time for some reasons, right? Granted, Google is in beta and has all the processing in just one command, but the output you get is, this might take up to 2 hours. Okay, let's wait 2 hours then, right? So it takes time. So it's a time-consuming process, and sadly, each cloud has his own limitations, and it's not easy. Also, we wanted to optimize this import process, right? So we didn't want to add more time, CPU-consuming time to our pipeline. And we didn't want to do image file conversions, right, from OBA to BMDK, back and forth, things like that. So we found out that BHD was the common format for all 3 clouds and on-prem, in our case specifically. So we went with that. So far, it's working fine, right? But we should be able to support all the formats. But for now, BHD is common for all 3 clouds, and it is working. So that's nice. So moving on, design. So again, we wanted to be cloud agnostic, and one thing that we had to consider to do that is we could have used the official Packer build for Amazon or for Microsoft or Google and grab a marketplace image, right? But what's the fun with that, right? And especially for us, working with the government agencies, they won't allow you to use a marketplace image, right? Let's be realistic. They won't allow that. They will block you right away. Most of the times, you don't even have access to the marketplace. So there was a decision between marketplace image or an independent ISO file that this could be locally stored. So we went with the locally stored, right? So we grabbed one, we hardened and everything. So that's why we couldn't use the Packer builders for each cloud, right? You have to do something generic that allow us to export to each cloud, right? That was something that we had to consider. And again, Hyper-V versus cloud-specific builder, that's the same, that's related, right? So Hyper-V allows us to use the BHD format that was allowing all clouds. So that was nice. And building this initial environment, this Hyper-V environment, that also took some time because we built it in Azure, Microsoft. So, but we should be able to do anywhere. But the initial configuration, networking, NATing, all that configuration, it requires some initial complexity there that you need to do. And mostly because of security, right? We were focused on supporting an air-gap environment like our customers. So even the initial Packer VMs that we create in the pipeline, those get internal IPs that you can reach from your internal network. You don't get public IPs at all in this pipeline, right? Everything is internal, so we had to consider those. But we added support for an added subnet. That way that somehow you get access, you are allowed to use external resources, we can map that routing and go outside and get those resources as well. So it was a nice balance there. So all that networking and everything was something that we had to think about, a nice design that was able to support both environments, air-gap and not air-gap. And again, we used TERRAFORM to do that, which was nice, so we could do a lot of, it could be extendable, that's the purpose. So we can do a lot of modifications, just do a TERRAFORM applying, it will be there. Or we can move all that to a different subscription or account and just use it there. So that was nice. So from the beginning, we had the idea to do everything as a code as much as we could instead of doing manually. So And that was a nice decision choice because it allows us to automate and save time in the long run. So yeah, so those are some of the lessons we learned along the way. But we have plans in mind. So it is working. It's a nice solution, but there are always next steps, right? Right now, sadly, we only support one subscription, one account, one project. But ideally, you should be able to support N subscriptions, accounts, and projects, right? Usually the way it works, you have a management account or subscription, and then you have other accounts and subscriptions are attached to this, right? Having a Spock architecture. So you just import those images to that specific management subscription, and from then you share those images to everywhere, right? So that's something that we have in mind, because if you start importing images everywhere, that's a pain. That's not going to work. It's really hard to manage those things, right? And I think we had the issue we had to import images everywhere. And
yeah, each cloud
it was a pain because who imported this image? Why it's still here, right? Things like, oh, we forgot to import to this other account that we didn't know existed. So that's why we want to centralize everything in just one managed account and from there share everywhere. And now our Jenkins slave is using service principals with keys, Amazon keys, those things, right? It is nice. Jenkins has a nice plugin to store secrets. But again, a more elegant solution will be to have slaves on each cloud and attach those identities to the slave itself, right? Using Amazon roles or Azure managed identities and GCP service accounts, things like that. That will be a more elegant solution. And again, we want to put some governance and policies in place for like how long are we going to keep these images, right? How to enforce development teams to use the latest version, things like that, right? Using Chef Server, we are using Chef Solo. I think that was just because it's easy. But using Chef Server will allow us to do a lot more things. And along with that, we want to support multiple provisioners, like Ansible and Puppet, right? Just be agnostic in all those things. And again, everything is going through containers and Docker, but the same architecture could be applied the same. So the next step is to start creating these image pipelines for containers.
Yeah, so.
Yeah, Nick, please.
Well, just tie it, yeah. Just every time we do any one of these things, we get all of our code out there. Everything that we can share, we try to sort of build something similar to what we did and put it into GitHub. So you can check that out at the HashiConf 2019 repo. You can look at our previous talk and also our previous code, which was less about gold images and where everything starts, to STIG automation in the operation stage. So looking at STIG drift, looking at like how your systems may shift out of compliance and how you can automatically remediate them without human intervention.
So this is mostly like what happens after you create a VM using our golden image, right? We want to keep that VM in compliance. So our Chef talks about how you can do that and automate that process, basically.
If you have more questions, if you feel like we didn't cover it here, you can reach out to us. We both have sites, emails, and Twitter, so you can hit us up there. And of course, you can reach out to us after the talk. Yeah,
we're going to be at the Microsoft booth for any questions, anything you want to ask. And if you guys want to grab some swag, it's going to be there too.
That's right, lots of swag. Thank you, guys.
Thank you so much, guys.
Very much.